Thank you very much. Good afternoon, everyone. I'm Dennis Clarijs, and my daughter is turning 9 years old next month. That's about the age that I was becoming fascinated by space. At that time, also, Dirk Vriemhout, our first Belgian astronaut, was sent into space with the space shuttle. I had this really cool nightlight next to my bed, which had the form of a globe, and I tried to impersonate Dirk Vriemhout while orbiting the Earth. I memorized all the countries around that globe at that time. Now, why is it that important to be looking at the Earth? I'll tell you. According to the World Resources Institute, I'm one slide behind, sorry. According to the World Resources Institute, we will have a population growth with 40% in the next 25 years. That's huge. They will have a higher living standard. They will live more in cities, in densely populated cities. So in order to support them, we will need more crops that can be grown all around the world. We need 56% more crops to sustain this population growth. We'll also need more protein products and so on. For their livelihood, for their living, we need 70% more wood. That's enormous. Also clean water, more energy and so on. That's what we will need to support this population growth. Now, to put that a little bit into perspective, to grow these crops and to support this population, we will need about 720 mega hectares to be available to support this growth. That is about the size of 240 times of Belgium. So we need to act and think carefully about how we do that. On top of that, we are having a planet under stress, climate change. We see rising temperatures, more climate extremes, more extreme weather, biodiversity loss, rising sea levels, and so on. I'm sure you will hear it all over the festival today. So this gives us an extra challenge. Now, the good thing is, if my clicker wants, okay. The good thing is we have nifty technology in space, satellites. And they come in many different formats. Just starting with a pop quiz here, does anyone know how many active satellites we have orbiting around the Earth? Anybody want to take a guess? Not asking my colleagues here.
10,000.
10,000? That's pretty close. We have actually 12,000 or nearly 12,000 active satellites in space. These satellites can go from matchbox size to school bus size, so there's a huge difference. You probably know satellites from global navigation, just as GPS and Galileo and so on, telecommunication satellites, or meteorological satellites to predict the weather. The satellites we are using are Earth observation satellites, and they are our eyes in the sky. They are taking the pulse of our planet. And in Europe, we're actually very good at it. We're actually top of the world, and that's because of the Copernicus program. That's the program in Europe that supports the launch of these satellites and the operations of it. Now, at VITO, we don't launch satellites. We collect the data, so we only start working whenever the satellites are launched. We collect the data, we process it, we calibrate and validate it. We want to make sure that the picture that you take 25 years ago can be compared with a picture that is taken this morning. So it's very important, and that's where we come in to do the science, to have consistent time series to take decisions upon. We need to make sure that we can compare apples with apples. If you have that consistent time series, you can deploy new algorithms, models on top of that. You can manage new data sets, and you can do or make advice and more research. Now, how many data are we talking about? In the European Copernicus program, we manage about 94 petabytes of data. And to put that a little bit into perspective, you all know this building, I guess. This is the Burj Khalifa, the tallest building in the world, about 1 kilometer high. if you would burn this 94 petabytes on a Blu-ray disc, I'm sure you're old enough to still know what a Blu-ray disc is, and you would stack them all together without the casing, you would have 2 Burj Khalifas. So that's huge. It's among the largest repositories like Netflix and so on. So it's a huge data set. Now, zooming in, back to Earth, what do we actually do with this data, with this 94 petabytes? I'll guide you through 4 thematics or use cases in which satellite data is used, and I'm only scratching the surface there. Let's start with our own food, the agricultural sector. The agricultural sector is the least digitized sector in the world. Yet, in Europe, 30% of all the budget go to agriculture. So that needs to be monitored carefully. So in Europe, there's a lot of subsidies involved, so they want to know what grows, where, when, and so on to have good statistics. Therefore, Earth observation is used. On a higher level, for example, the United Nations Food and Agriculture Organization uses this data to see and compare along long-term time statistics to see where there are vulnerable areas in terms of crop yields and so on. That will give them the power to use or to negotiate on a higher level to see where there are crops excesses, yield excesses, and so they can prevent starvation. More on a local level, on the fields or farmers here around the corner, they use this data to look into their fields. They can do smart farming with it, precision farming. They can look at their fields, what is happening, where they need to irrigate, where they need to fertilize, and what the best moment is to get their yields in. Also, the agriculture insurance sector, for example, they can see which fields have most risks if you look at the temporal statistics. But on the other hand as well, they can use this data to do automated payouts on top of this data. A second case is the oil and gas industry. Large energy companies pledge to be supporting the green transition, the green energy transition. So they use this information to see where they can put wind farms, where's the most solar radiation for solar farms. We can measure, for example, snow depth, water equivalents to see where hydropower plants would make sense. On top of that, they can also look at the risk of their infrastructure. They can measure methane from space and other emissions. So very important to have this information from space. On top of that, they can do carbon verification, carbon sequestration, follow that up. So it's very important to have the space data available in this sector. And another example, there we go to cities. Most of the growth of the population will live in cities in the future. So it's very important to take a look at that as well. And did you ever wander around in cities where you could feel the heat from the buildings, from the road? I guess this part of the audience can feel it right now. This is called the urban heat island effect. And it says that it can be 11 degrees hotter than just outside of the city. So that's huge. And the high temperatures, they are linked to air quality deficits, to health problems. And about 100,000 people on a yearly basis lose their lives because of the high temperature link or the exposure to high temperatures. So it's careful to manage that. So putting more green into the city is a solution. And a good example of that is Paris, where they made some hard decisions already quite some time ago to be ready for the Summer Olympics. They managed to get more green into their cities, more bike lanes, managed to keep cars outside of the city. And as a result, they have declined or decreased the carbon emissions, carbon dioxide emissions in these 70 years with 50%. So good decisions were taken there. Not sure who remembers this event? Summer 2021, southern part of Belgium. I still do. I still remember this one. The evening after this event, I got a phone call from the Civil Security Service telling me, Dennis, we are still looking for 35 people. It seems that you might have some additional information that might help us find these people. At that time, our researchers and engineers just went on their holiday season. So, but they felt the sense of urgency. So we started working on data, on radar data in this case, because it was cloudy and you can't use optical data to see through the clouds. And we were able to map the water bodies all around that area. And this map could be used to for the Civil Security Service to make use of and to guide their search and rescue actions. Now, Earth observation cannot only be used in or whenever a disaster strikes, but also to prevent it. We can measure from a millimeter level subsidence, buildings that are subsiding. We can also see where fire risks are by measuring soil water index and so on. Now, some positive news. All this data is open and freely available from the Copernicus program. We have platforms like the Copernicus Data Space Ecosystem and Terrascope.be that visualizes this data, where you can compare the data, the whole time series, and you can even invoke custom processing. So these are very nice tools to use the satellite data. Now, when I explain my work to people, they often ask me, okay, if all this data is open and freely available, can they see me in my underwear in my backyard? I can assure you that's not what we're doing. There are very high resolution satellites that can be tasked to do it, but it cannot be cloudy that way. I don't think anybody will see your underwear, and we're for sure certainly not interested. A product that we built looks like this. This looks like an artist impression of Antwerp, city of Antwerp, but it's actually the result of trillions of pixels of processing of radar data and optical data. This is a base map, a land cover map that is processed for the whole globe and where we can see changes in the world. It's also used as a base map for future modeling and so on, but also to see at deforestation. A good example of this is the European deforestation regulation that is coming up at the end of the year, where companies, large-scale companies that want to put agro-commodities on the European market, they need to prove that from 2020 onwards, they didn't cause any deforestation in the world. So these maps are the start of their journey. Now, where are we heading off to? So we're building Earth's digital twin. Imagine that you had on your cell phone some kind of an app, but instead of predicting the weather for a week or for 2 weeks, it would give you events on air quality, how urban heat islands would evolve, what the impact on food security is. You name it, we can look into the future with this data. We have many new technologies coming up as well. We have, for example, only in Europe, about 100 new satellites that are being launched in the next 10 years, Earth observation satellites. In the whole globe, we have about 1,200 new satellites being prepared for launch for next 5 years even. On top of this, we have artificial intelligence rising, accelerating. We have new foundation models, we have embeddings, we have agentic AI and so, which is helping us with searching through this explosion of data. On top of that, processing will go more on the platforms, on the satellite itself before the data is downlinked. And we will have more supercomputers being hooked up to scientific networks, not to mention quantum computing. So I'm very positive that all these evolutions will help us predict the future even better. And the future, this is my future. This is my daughter. She when I prepared this talk, I actually talked to her about it, and she was very interested. And she actually confiscated my nightlight of 35 years ago. So I hope I was not only an inspiration for my daughter, but I'm sure if we continue to embrace this technology, that we can support the sustainability on Earth, our resilience for our planet, because we only have one. Thank you.